an electrolyte. AB is a substance, is going to ionise to gives rise A plus and B minus. So these ions are responsible for migrating under the influence of some electric field. According to Ohm's law, what is V is equal to IR. I is the current, R is the resistance. R is equal to V by I, and I is a current in amperes, and electrical resistance ohms. At infinite dilation, when ionization is complete, each ion has a tendency to migrate independently and contributes to the total molar conductance. That is what is called Kohlrausch law. Hello my dear students, welcome to one more amazing session from Sri Chaitanya Academy. This is Suresh, faculty of chemistry. आज हम चर्चा करने वाले हैं इलेक्ट्रोकेमिस्ट्री वन शॉट सीरीज में पार्ट 2, क्योंकि ये इतना लंबा चैप्टर है. पार्ट 1 सेशन में इलेक्ट्रोलाइटिक सेल्स, गैल्वानिक सेल, नर्न्स्ट इक्वेशन, एवरीथिंग वी डिस्कस्ड इंक्लूडिंग इलेक्ट्रोकेमिकल सीरीज एंड thermodynamics of the electrochemistry. And today we are going to focus on conductivity. Conductance, electrolytic conductance is very important question, and it is being asked for every year at some probability, and expect a very good question from electrolytic conductance. So there we are going to study conductivity and molar conductance and equivalent conductance, Kohlrausch law and its applications, and we are going to discuss some numericals based on this also. And please like this session and share with your friends. Subscribe to Infinity Learn and Sri Chaitanya Academy YouTube channel. And in the electrolytic conductance, so what is a conductor? A substance which allows the passage of the electricity through it is called conductor. You have two types of conductors. One is a metallic conductor, another one is a electrolytic conductor. Metallic conductor is also called as electronic conductor. It's a copper wire. So we just give to the physics. Coming to the chemistry, an electrolyte. What is an electrolyte? Let us consider an electrolyte. AB is a substance, is going to ionise to gives rise A plus and B minus. So these ions are responsible for migrating under the influence of some electric field, which leads to the conductance. So that is what is called electrolytic conductance. The conductance due to the ions is called electrolytic conductor. And let us see the details about the electrolytic conductor here. Electrical resistance and resistivity we will discuss. From their conductance we come. And you see resistance by a metallic conductor, a cross section is taken and a length is taken. Let us simply apply Ohm's law. According to Ohm's law, what is V is equal to IR. I is the current, R is the resistance. R is equal to V by I, and I is a current in amperes, and electrical resistance ohms, and potential difference V voltage. And in that, electrical resistance of the conductor is of two types: directly proportional to the length of the conductor or inversely proportional to area of cross section. So based on that, R is directly proportional to L and R is inversely proportional to area of cross section, so that R is directly proportional to L by A. So that I want to make it as a constant. R is equal to rho L by A. Rho is called constant proportionality, it is called specific resistance. And you see, talking about that, unit of resistance, you know, ohm, or constant of proportionality R A by L, known as resistivity or specific resistance. So you take the dimension here, ohm centimeter square by centimeter. So this is considered to be, when L is equal to 1 centimeter, A is equal to 1 centimeter square, that is called specific resistivity. And resistance offered by 1 centimeter cube electrolyte is called specific resistivity. And in that, as per IUPAC, resistivity recommended over specific resistance, and rho is important for us. And unit for this is going to be, SI unit is going to be, unit is ohm centimeter. And you see, for a substance, resistivity is a resistance when 1 centimeter long and area of 1 centimeter square, it comes to the electrolytic solution, it is going to be 1 centimeter cube electrolyte. And moving ahead, so interconversion, electrical resistance and resistivity. So interconversion of the units, 1 ohm meter is equal to 100 ohm centimeter, 1 ohm centimeter is equal to 0.01 ohm centimeter, because this conversion is important as far as some questions are directly given in the SI units in the NCERT. So to solve the questions from the NCERT, it is required. Moving ahead, but you can see, you measure platinized electrodes are taken, and this is the electrode. The distance between these two electrodes is 1 centimeter L, and this is the area of cross section. And when you connect it, the solution present here, the electrolyte is going to offer some resistance, and the resistance is measured by using Wheatstone bridge. And like any metallic conductor, electrolytic conductor also offers some resistance to flow the current. And that current, resistivity of an electrolytic conductor is the resistance offered by 1 centimeter inverse 1 centimeter cube electrolyte, and that is given as 1 centimeter cube. How this 1 centimeter cube come? The distance between these two is going to be 1 centimeter, and it is going to be 1 centimeter square. So together you are going to get 1 centimeter cube. So this is the electrolyte quantity present in between 1 cm cube of the imaginary electrolyte, and from there only we are going to see specific conductance as well. So you know R is equal to rho L by A, and G is going to be 1 by R, where G is going to be conductance, and it is a resistance ka inverse hoga, and G is going to be A by L and rho, and A by L you see here, and it is represented by G, conductance. And you are coming to a cell constant called G star here. In G star you are going to be G is equal to 1 by rho into A by L. So it is said to be 1 by rho, it is itself is a constant, and it is said to be K, and this is called conductivity or specific conductance. It is defined as, specific conductance is defined as the conductance offered by 1 centimeter cube electrolyte, and this is measured in SI units Siemens and ohm inverse or mho. Better you use Siemens and ohm inverse according to the NCERT. And let us talk about the conductivity K. K is equal to 1 by rho. The inverse of the resistivity is called conductivity or specific conductance. So G is equal to 1 by R, as you know pretty well. K is equal to 1 by rho, 1 by R into L by A, and K is equal to G L by A. L by A is said to be cell constant G star, and it is said to be, when it is L is 1 centimeter and A is 1 centimeter cube, it is going to be K is equal to G. So specific conductance is nothing but it is the conductance offered by 1 centimeter cube electrolyte. So conductance of the solution placed in between two electrodes separated by 1 centimeter apart, and the area of cross section is going to be centimeter square. So the electrolyte volume is going to be 1 centimeter cube as mentioned here. So this is the key point. By using this definition you can calculate so many numericals based on this. And moving ahead, you can see this is what is called R is equal to rho L by A. L by A is said to be cell constant. As long as the device is constant with respect to of any electrolyte, the cell constant is always constant, and it is given as G star, and G star is equal to L by A. We can write this as L by A and R by R. G star is equal to here, G star is equal to L by A R into R is equal to K. So G star is equal to K R or R K you can write. So simple formulas where you can calculate numericals based on NTA NEET examination 2026. So get ready, we are all helping you to solve the questions and giving you the concept in one shot series in electrochemistry and various parts of the physical chemistry points. Here you can see generally you take a KCl solution is used to determine the cell constant, because KCl is readily soluble in water and it do not interfere with any of the electrolytes, and it is going to be measured by using KCl. So this point is also important. Which of the following salt is used to determine the cell constant? KCl. And moving ahead here, conductivity of ionic solutions, as you said, specific conductance is equal to G star upon R. R is the resistance. So the conductivity of solution of different electrolytes is given, depend upon the various factors. So which of the following depend and which of the following is independent is going to be a very good question in NEET examination, and we are giving you the information to you guys in this YouTube channel. So boards के साथ NEET भी पढ़ाना है. अभी तो आपका NEET preparation चल रहा है, but this is a time where board examinations. So when you focus on the board examination, in this session we give the quick concept revision, and we are not leaving you that NEET examination preparation. So let us see the various factors that are responsible. Nature and charge of the ions. So conductance is directly proportional to the magnitude of the charge. Let it be a cation or anion. And concentration of the ions. As concentration decreases, conductivity increases, of course. And of course, ease with which the ions move under the potential gradients or electric field. So these are the various factors, and we will discuss in each and every point in this. So conductivity, it becomes necessary to define physically more meaningful quantity, molar conductivity. So what happens when 1 centimeter cube electrolyte is taken? When you add water, so solution is getting diluted. So in that defined 1 centimeter cube, the number of ions decreased. So the conductivity offered by the number of ions decreases. Specific conductance decreases on dilution. But if you define the molar conductivity, that comes into the new picture. So it is a more precise way, molar conductivity or equivalent conductivity. So simply you take the concept of the molar conductivity here. So the molar conductivity is denoted by the symbol called lambda, so capital Greek. So you can also say another one is, that is ionic mobility. You have two terminologies again. This is given molar conductivity at a specific defined molarity or concentration, and this is defined as when the concentration decreases and almost the concentration is 0, that is called infinite dilution, and this is the magnitude. You can say it is a molar conductivity or limiting molar conductivity or molar conductivity at 0 concentration or molar conductivity at infinite dilution. That is the game changer in the total chapter you study about the conductivity. So it is the conductance of ionic solution containing 1 mole per liter of electrolyte between 2 electrodes. So जब molarity 1 mole per liter होगा, ताकि ये conductivity molar conductivity बोल सकते हैं आप. Are you getting or not? It is simply calculated by using this. Conductance is equal to Kv, and V is the volume of the solution having 1 mole of an electrolyte, and you can simply use this K value there and you put this, you are going to get 1 mole of the electrolyte. जब concentration C बोलेंगे, molarity you can say C is the concentration, and 1 mole of electrolyte will dissolve in 1000 by C milliliters. So usually you take experimentally in milliliters, but you solve the questions in liters. So a weird examples in the chemistry, especially in the electrochemistry here. And molar conductivity, just this is a super awesome. There are 5-6 numericals are there from the NCERT textbook, that is given as molar conductivity is equal to specific conductivity into 1000 by molarity. Bas. You can calculate 5 to 6 numericals directly from the NCERT. So the same question, maybe values are changed, and the same type of questions you are more prone for asking in NEET examination, that आने वाला है 2026 में तैयार है सब लोग. So coming to the molar conductivity here, you have various versions to calculate this. K is expression Siemens centimeters inverse and C is in mole centimeter cube. So if it is going to be molar conductivity, you are going to get specific conductivity. So it should be Siemens centimeter inverse and 1000 and centimeter cube liter inverse, and molar conductivity molarity mole liter inverse. So सब मिलके एक डायमेंशन आपको मिलेगा. Siemens centimeter square mole inverse is the dimension for molar conductivity, and you can say unit of molar conductivity is Siemens centimeter square mole inverse. You can answer SI units, Siemens meter inverse K ka, and it is going to be Siemens meter square mole inverse. So that is the SI unit of the molar conductance. So generally NTA follows SI units. So it is very important, and you just take a pen and paper and note these SI units, and always use SI units on paper, but experimentally it will be given centimeters and mole inverse into the action. So experimental centimeters used and numericals meters are used. So Siemens meter square mole inverse is the SI unit. So taki moving ahead, interconversion of the molar conductivity. This is super important. So 1 Siemens meter square mole inverse is equal to 10 raise 4 Siemens centimeter square mole inverse. So that 1 Siemens centimeter square mole inverse is equal to 10 power minus 4 Siemens meter square mole inverse. So you just say 10 raise minus 4 Siemens meter square mole inverse, and it is there. And equivalent conductivity, I'll tell you, it is also looking little complex phenomena. It is not at all a complex phenomena. I'll give you a simple trick. Specific conductance offered by 1 centimeter cube of electrolyte. Coming to the molar conductivity offered by 1 mole per liter. जब molarity 1 होगा ना, 1 mole per liter electrolyte. So instead of you take molarity, if you take a normality, that is going to be equivalent conductivity. I don't want to give a prolonged explanation for this. It is pretty simple, and equivalent conductivity denoted by the symbol simply lambda EQ. EQ stands for equivalent conductivity. At a given concentration, and the conductance offered by 1 gram equivalent of the solution separated by 1 centimeter apart to electrodes is called equivalent conductance. Here again 2 types. What is this or what is this? So equivalent conductance at given concentration and equivalent conductance at 0 concentration. So you can calculate this as well as on this, and you can calculate this, and you can theoretically calculate this by using Kohlrausch law. Get ready, I am going to show you how it can be done. So again the same thing, you don't have to worry, just like molar conductivity. You see, equivalent conductance is equal to specific conductance into 1000 upon normality. N stands for normality, where in molar conductance M stands for molarity. So it is going to be, when the volume is in milliliter, in the same way you can say. So Siemens centimeter square and equivalent inverse is the same dimension. Siemens meter square equivalent inverse is the SI unit, and if it is an experimental, Siemens centimeter square equivalent inverse. And when you take molarity, molar conductance, when you take normality, that is equivalent conductance. That simple version. And how this equivalent conductance and molar conductance are related. And you see, conversion into the volumes, liters into the centimeters, meter cube and milliliters. 1 liter is equal to 10 power minus 3 meter cube and 10 cube centimeter cube. And in this way you can say simply it is Siemens centimeter square equivalent inverse. So this is mathematically calculated and it is pretty well, and ये याद रखना and SI unit में ये याद रखना, ये super important का है. And equivalent conductance is the one which is not specifically given in the NCERT but it will be asked in the NEET examination, क्योंकि normality molarity NCERT में है, सिर्फ interconversion का हिसाब से आप कर सकता. So yes, and how I am giving you this session, boards versus NEETs, Sri Chaitanya Academy from the NEET Academy, right? We are doing all the questions based on the NEET as well as on board. So dual preparation and double preparation, concept oriented, more important things. If a resistivity of 0.8 molar KCl solution is 2.5 into 10 raised minus 3, you are asked to calculate directly molar conductivity. So it is given a specific conductivity is equal to here 1 by resistance into 1 by, and what is this? The resistivity is given. Okay, you are going to say here it is 2.5 into 10 power minus 3. You are asked to see this is answer comes to be 1 by 2.5 into 10 power minus 3 comes to be 400 ohm inverse centimeter inverse. So that is a very important model. Okay, so the concentration is taken, and as we know the formula, you can say molar conductance K into 1000 by molarity. You have the K value now, and 1000 is the unit here, conversion of centimeter square into liter inverse, and molarity, the question itself is given the molarity, it is going to be 0.8. When you plug these values, you are going to get 5 into 10 raised Siemens centimeter square mole inverse is the answer for this question. And like that you can calculate so many things, and I want to show you one more couple of questions. So sometimes you see NEET examination multiple choice question mein aana hai, and see this question, I want you to solve this question and put this answer in the chat box. So I am waiting for your answer here. And resistance of 0.2 molar solution of an electrolyte is 50 ohms, and the specific conductance of the solution is 1.4 Siemens meter inverse. You see here SI units it is given, and the resistance of the same cell when it is filled with 0.5 molar solution, the same electrolyte is given to 80 ohms, and the molar conductivity of this 0.5 molar solution of electrolyte is asked. How much a solution ka? You have two solutions, one is 0.5 molar का और एक 0.2 मोलार का. 0.2 मोलार का वैल्यूज दिया, 0.5 मोल का निकालना है, and definitely you can do it based on that cell constant निकाल दे, and based on that cell constant you can calculate the specific conductance and you can calculate the molar conductance. Here it is given C1 0.2, R1 50 and K is equal to 1.4, it is given, right? And C2 is given and R2 is given. You are asked to get molar conductivity kiska? C2 ka, right? For R1 50 ohms, as we go, K is equal to G star nikal, and it is going to be G star is calculated as 1.4 Siemens meter inverse 1 by 50 inverse into G star, and G star comes to be 70 meter inverse. I am following the sanctity in following the same dimension in the class. So if you maintain the dimension and analysis, even in the physics and chemistry, you are going to get awesome numericals, and you can just see here. So for R2, you just plug here G star, you can calculate K, 1 by R resistance in G star. G star is always constant, जब तक cell constant है, इसका cell constant भी constant है, and it is 70. We calculated in the previous slide, it is given already 1 by 280, and K you got it 0.25 ohm inverse. When you have this 0.25, you can plug in the molar conductance formula, and in this molar conductance K into 1000 by molarity, but 1000 liter में convert ना, 1000 नीचे आएगा, 0.25 into 1000 into 0.5. On solving, you are going to get 5 into 10 raised negative 4 Siemens meter square mole inverse. This dimension is also very important, so that from this question, I say option 1 is the correct answer for this question. Are you getting or not? It's a super question. Undoubtedly, if you can solve this type of question, CBSE examination, JEE board examination and NEET examination, and it is yours. Don't leave the mark on the table, put the mark in your pocket. Ready for that? And so please like this session and share with your friends and subscribe to Sri Chaitanya Academy Infinity Land NEET YouTube channel, so that we will be giving so many concepts and questions based on this. And stay tuned and let us do the best. And here one more question, and you can do it and read the question. Resistance of electrolyte, resistance of conductivity cell filled with a solution of an electrolyte of a concentration 0.1 molar का 100 ohm दिया, right? And the conductivity of this solution is 1.29 Siemens meter inverse, and now the resistance of the same cell is filled with, same cell na, cell constant है, and it is filled with 0.02 molar of the same solution is 520 ohms is the resistance, and the molar conductivity of the 0.02 molar solution of the electrolyte will be, again options are given. You can do the same question in the previous model. Make a try. So when you try this, look at this, given C1 0.1, R1 100 ohms, and K is equal to 1.29, and C2 is 0.02, R2 is 520, and molar conductance किसका 0.02 mole का लिखा, and if you do so exactly cell constant you are going to get as 129 meter inverse. As I said, this is a replica of this previous question, and take this cell constant and calculate specific conductance K here. So put that K is equal to 1 by resistance into G star. G star अभी 129 निकला, 520 का दिया. So put this 1 by 520 into 129, you are going to get 0.248 ohm inverse meter inverse, and from this K you can calculate molar conductance, and this molar conductance is equal to K by 1000 into molarity when you are taken in the meters SI units, and it is going to be 0.248 upon 1000 into 0.02 comes as 124 into 10 to the power of minus 4, and the option for this question is going to be, look at this question, in this question option is going to be 124 into 10 power minus 4. So sometimes numericals are important. In the total NEET examination paper you will be having a couple of numericals, so hardly you can expect 6 to 8 numericals, not more than that. Remaining thing is going to be theory oriented and not so complicated derivative oriented. You say NEET preparing students simply say I am not good at mathematics, I am weak in mathematics. So it do not require mathematics. You see simple divisions and multiplications, my dear children. And if you are good at approaching the question, you can do the best, and all the best, my dear students, and we'll see. So bachcho, variation of conductivity of molar conductivity concentration is very important concept. In the NCERT direct graph is given, you are going to say Debye-Huckel-Onsager equation. The equation is not given, but the term Debye-Huckel rule is given. So the both conductivity and molar conductivity changes with the concentration of the electrolyte. Yes, I said dilution में क्या होगा? Concentration is going to be decreased. So effect of concentration change. You have conductivity and molar conductivity. Conductivity means you can say specific conductance, bachcho. In this conductivity, let us say two versions. So as the specific conductance, when you add water or a solvent, you are going to see a dilution. So the distance between ion to ion increases, so that 1 centimeter cube में number of ions कम आ जाएगा. So that as a result number of ions are less and the conductance provided by this is going to be decreased. So conductivity is the conductance per unit volume. Assertion reasoning questions. I want to say conductivity always decreases with a decrease in concentration on dilution. You can say it is for both weak electrolyte and strong electrolyte. If you assume this is a assertion and this is going to be a reasoning questions. So both assertion, reason are correct and the reason is the correct explanation for this assertion, and this is the way you need to prepare boards as well as NEET examination. Children, focus on the concept. NEET examination, I don't want to say NEET, NTA is focusing on how complicated numerical you can do, but it will focus on what is your understanding ability and how you use the understood concept in a real time questionnaire, and it is going to investigate the understanding ability, right? It is not if you do 100 questions in electrochemistry, 500 questions in electrochemistry, आपको कुछ फर्क नहीं पड़ता, but how confident in analyzing a given point is very important. This is a crystal clear example that I want to give you, and you do the best. Please like this session, share with your friends. So ये ऐसे points आपको मिलने के लिए. So आगे बढ़ो, and moving ahead here I want to say on dilution number of ions per unit volume decreases. Reasoning. Also conductance depends upon the number of ions as well, right? And conductivity decreases on dilution. So this is the hierarchy of the learning process. Whenever you prepare, you take a pen and paper, write one point to the another point like that. And talking about molar conductance. So what happened? Conductance of a solution depends on number of ions. Of course, molar conductance increases with upon dilution. ये उल्टा क्यों? On decreasing on decreases on dilution on concentrations. Yes, of course, the reason is that different for electrolytes. For the strong electrolyte का अलग होगा, weak electrolyte का अलग होगा, but दोनों increase होगा. I wanted to say when a solution is diluted, specific conductance decreased. Reason, number of ions per unit volume decreased. The same when you talk about the molar conductance or equivalent conductance on dilution, it is going to be increased because degree of ionization is increased. But increasing pattern जो होता है ना, it is different for strong electrolyte and weak electrolyte. A strong electrolyte is one which ionizes completely when you dissolve in the water, and weak electrolyte is the one which do not ionize completely. So that is explained here by using various reasons here. So reason, strong electrolyte. So on dilution the strong electrolyte, molar conductivity increases as of course steadily increases, and due to decrease in the ion force of attractions, of course. This is about the strong electrolyte. Example, potassium chloride. And for a weak electrolyte you can take CH3 COOH. It is going to ionize weakly CH3 COO minus and H plus. Okay. On dilution molar conductivity increases. So due to the increase, both are increases, you see, both are increases. I want to say increases steadily and it is increases suddenly. So that is the difference. So due to increase in the degree of dissociation of a weak electrolyte increases. So that when you see a graph here, I will show you with the dilution the influence of other ions on the movement decreases. At a particular dilution the ion becomes totally independent on other ions. That is what is given by Kohlrausch law of independent ionic migration. And at this point the ion contributes maximum towards the conductance of the electrolyte. So every point is explained on the granular level and you can do it, and it is explained. Limiting molar conductivity, mean to say conductivity जब molarity 0 होगा ना, you can say limiting molar conductivity, or conductivity at 0 dilution or infinite dilution, you can say 0 dilution. and various symbols are given. Limiting molar conductivity, this value of molar conductance at the particular dilution is known as a limiting molar conductance. So, at a particular dilution means infinite dilution mein hoga. In other words, when concentration tends to 0, approaches 0, and then molar conductivity is known as limiting molar conductance, and molar conductivity at infinite dilution you can say. That is the reason why I have written infinity there. And when you see here, the represented by lambda naught or lambda infinity, and look at this, the variation of molar conductance and concentration for strong electrolyte and a weak electrolyte. So, let us see how it is done. So, I want to give you here for a strong electrolyte, for the strong electrolyte, say an example KCl, the moment it dissolves in the water, K plus and Cl minus, it ionized, but on dilution, ion ka ion distance is increased, intermolecular inter-ionic forces decreased. So, that ion is going to more easily moved. So, it increases slowly or steadily. I want to give you reason, no abrupt change in the number of ions with dilution. That is the reason why if you take a graph between molar conductance and root concentration, you are going to get a straight line like this. You are on extrapolating this one. This gives you molar conductivity at infinite dilution according to Debye-Huckel-Onsager rule, and it is given. So, concentrated solution, strong attraction between the ions and slow down in the migration of the ions or movement of the ions. With the dilution of ionic solution, what will happen? Distance between ions increases. So, decreases inter-ionic attractions, so that it gradual increase in the molar conductivity of the solution is seen. So, that is what it is. So, this is what is called as Debye-Huckel-Onsager rule. This is a very important rule, and this rule is not given in this version, but this rule, the term is given in the NCERT Debye-Huckel rule, so that you can use this equation. Molar conductivity at a given concentration is equal to molar conductivity at infinite dilution minus A into root C. C stands for concentration, A is a constant. So, मेरे को लग रहा है Y is equal to mx and plus C. So, I want to say here, if you take molar conductance and root concentration, you are going to get a straight line with a negative slope, क्योंकि negative लग रहा है ना, and it is going to be limiting molar conductance and it is going to be intercept A. And this graph is very important. If you have any doubt, please mention in the comment box or a chat box, so that we can just reciprocate you guys. And if you talk about, yes, exactly it is given in the same way, molar conductance and the root concentration, C stands for molarity. And you have to look this here, from here, from here, from here, the concentration is decreased. And you can extend it. On extrapolating, you are going to get it is a limiting molar conductance, and its slope is going to be negative A, and depends upon the type of electrolyte. There is a what I can say, steady increase in the conductance. Moving ahead here, so it is a straight line. As I mentioned, it is an intercepting and it follows equation of straight line. If you have any doubt, please let me know. And moving ahead for out the weak electrolyte. So, types of electrolytes. So, electrolyte changes on this dissolution. Sodium chloride, so sodium plus and Cl minus. Calcium chloride, calcium 2 plus and 2Cl minus. Magnesium sulfate, magnesium 2 plus and SO4 2 minus. So, all the electrolytes of a particular type, same amount of charges on dissociating the ions, the value of A. Same for all electrolytes. Here, when you talk about here, variation of molar conductance of weak electrolyte. So, what is a weak electrolyte? So, we can say weak electrolyte CH3, COOH, it is reversibly gives rise CH3 and COO minus and H plus, right? And at higher concentration, weak electrolyte like acetic acid has a lower degree of ionization, and with dilution, at the dilution ionic solution, the degree of dissociation alpha increases. Oswald dilution law. So, increases the number of ions in the solution. So there is a steep or sudden increase in the molar conductance near lower concentration. So, it increases suddenly. So, it appears like this. If you observe potassium chloride, it was like this. But of course, acetic acid initially its conductance is very less. If you add some water into that, dilution will happen, there is a sudden increase. We do not know where it is going. We do not know where it is going. So, you can't use Debye-Huckel-Ansager rule to calculate the molar conductance of a weak electrolyte. So, there is a sudden increase for this weak electrolyte. That is the difference between the strong electrolyte and a weak electrolyte. So, for that I can say here the weak electrolyte is increased. The curve for the weak electrolyte is a rectangular hyperbola, and the terminologies are very important for the NEET examination, bachcho, and does not intercept in the y-axis. It is going somewhere, we do not know where it is going, right? It may intercept somewhere at the some infinite position, right? That mathematically you can't calculate it, isn't it? And moving ahead, although the concept of molar conductance at infinite dilution exists for even for the weak electrolyte, but graphically the value cannot be evaluated because the graph is going somewhere. So, we need something or the other concept called Kohlrausch law. Ready? I am going to give you the Kohlrausch law. If you get a question from this particular concept, definitely you are going to get it from Kohlrausch law. I am going to give you Kohlrausch law of independent ionic migration. It says, Kohlrausch law says at infinite dilution, when ionization is complete, each ion has a tendency to migrate independently and contributes to the total molar conductance. That is what is called Kohlrausch law. I mean to say here, I do not want to show you if you say NaCl and KCl, their values are given and this values product is calculated, and if I say in the simplest way, if AB is an electrolyte is ionizing to gives rise A plus and B minus, and the molar conductivity at given infinite dilution is equal to ionic mobility of A plus and ionic mobility of B minus, and dono sum karna. If it is given for X and Y, it is going to be X and it is going to be Y, right? So that you just multiply with X and you just multiply with Y. That is it. You can do for any type of equation, and you have various numbers due to the difference in molar conductivity of Cl minus and NO3 minus. So, you have to multiply with respect to ions number, okay, that is at infinite dilution when all the interionic effects disappear, because independently the ion is going to be migrated. Why? Because ion is separated at infinite distance apart. There is no attraction force and there is no repulsion force among the ions, and towards molar conductivity they are going to produce. So sum of the molar molar conductances, you see, sum of the ionic mobility is equal to the total molar conductance, that I want to show you here. So you can say limiting molar conductivity of an electrolyte can be represented as the sum of the individual contributors. Say an example, mathematically molar conductance is equal to ionic mobility is a limiting molar conductivity of a cation, limiting molar conductivity of ions. If you take a NaCl, let it be KCl, okay, it is going to be ionic mobility of sodium plus ionic mobility of Cl minus. Let us see some factors you can talk about here. So, AXBY, X moles of AY plus and Y moles of BX plus. So, you take V plus and V minus are the numbers of cations and anions respectively in this equation. You want to do calcium chloride, calcium 2 plus and 2Cl minus. So, the molar conductivity is equal to ionic mobility of calcium 2 plus and 2 into ionic mobility of Cl minus, क्योंकि 2 Cl minus ions are there. That's I want to show you here. That is given if it is going to be aluminum sulfate ka. 2 aluminum 3 plus 3 sulfate ions are there. So, 2 aluminum ionic mobilities plus 3 sulfate ionic mobilities. So, it is very simple. NCERT also some questions are being given and you can solve these questions with a lot of enthusiasm and you can do it. And also you can see limiting equivalent conductivities. The limiting equivalent conductivity as of this molar conductivity is same pattern, but only n factor is going to be changed. So, the same way the relation between the molar conductivity and the equivalent conductivity. Equivalent conductivity is equal to molar conductivity by n. N is the n factor you study with the normality, है ना? Right. So, molar conductivity is equal to n into equivalent conductivity. जैसे आपको normality is equal to n into molarity. That's the reason why you don't say equivalent conductivity is equal to n into molar conductivity. And my dear students, this is absolutely wrong concept. This is a wrong concept. Why? Because students misleaded with this formula, but the correct formula is this. Everybody take a note of it. Calcium chloride solution. You can say here you don't have to use this 2 number here because you are already taken the normality, उसमें n already multiply किया. Similarly, calcium chloride का and molar conductivity. So, equivalent conductivity is equal to ionic mobility, molar ionic mobility of calcium plus molar ionic mobility of Cl minus divided by 2. So, charge on the Ca2 plus and charge on the Cl minus comes into the picture here. So, the conversion even for this aluminum sulfate, you need not have to do anything. Simply you calculate molar conductivity and equivalent conductivity and divide the n factor. Aluminum sulfate का n factor कितना होगा? Chart box में डालो. Okay, right? We'll see here aluminum का n factor is going to be 6. If you recall normality concept, you will come to know, isn't it? Fine. And here it is going to be the same way. And let us see, it's a super concept. It is, we are giving this session, so boards के साथ NEET parallelly preparation चलते रहते हैं, isn't it? So you can say the limiting molar conductivities for sodium chloride, potassium bromide and potassium chloride are, some values are given, 126, 152, 150 Siemens centimeter square molar inverse, and the value of the molar conductivity of sodium bromide. So, how to give this kind of answer? Simply sodium bromide ka a given data, from this given data you just write these ions and their ionic conductances are given and you tally and correlate just what you did in the thermochemical equation like that. And you can see here given sodium chloride, potassium bromide, potassium chloride. Sodium bromide का कैसे करूँ? So, sodium bromide is equal to sodium chloride, potassium bromide and potassium chloride. So, minus potassium chloride you can say. So, that as potassium is subtracted you can this and chloride is subtracted, you can do this. So, Na and Br is left, isn't it? So, you can use this value, it is given 126, NaKbr it is given 152, and it is given KCl it is going to be 150, and 126 plus 150 minus 152 minus 150. On doing so, I am going to get 126 is the answer, 128 Siemens centimeter square mole inverse. So, I want to give the answer as A. Students, moving ahead, it is a question from, direct question from Debye-Huckel-Onsager equation. The question is asking the equivalent conductance of NaCl at concentration C, the concentration is given, you can say it is a C mole per liter, and at the infinite dilution it is given as limiting molar conductance, and at a given concentration it is given molar conductance at a given concentration, and it is limiting molar conductance. The question is the correct relationship between molar conductance at given concentration and molar conductance at infinite dilution is given as. So, it is directly based on Debye-Huckel-Onsager equation. Different options are given. What Debye-Huckel-Onsager equation says? It is there, the equation is not given in the NCERT, but the word Debye-Huckel rule is given. So, according to this, molar conductance at given concentration is equal to limiting molar conductance, mean to say molar conductance at infinite dilution minus B root C. B is a constant. So, C is the concentration. So, based on that, you can say the option is going to be here. Option A is the correct answer, and according to this, option B is the correct answer. It says according to this, option C is the correct answer, and this question is related to Debye-Huckel-Onsager equation. And moving ahead, Al2SO4 thrice, and this solution is given, limiting molar conductivity of Al2SO4 thrice is given as, Al2SO4 thrice is completely ionized, you can say, 2 Al3 plus and 3 SO4 2 minus, in that its valency factor is 2 and its valency factor is 3, and the number of ions, and this is 2 ions carries 3 charges and 3 ions carries 2 charges. So, the total value is going to be 6, so that it is going to be molar conductance of Al2SO4 thrice is going to be ionic mobility of aluminum 3 plus into 2 plus ionic mobility of sulfate into 3. So, it is going to be a very useful formulas that you can make it to solve the questions based on this. And I just want to say an overall picture about the limiting equivalent conductivity of constituent ions. It is given as, at infinite dilution, it is going to be the sum of ionic mobilities of equivalent molarity, equivalent conductances of the constituent ions. Let us say equivalent conductance, if it is given as AB, and it gives rise A plus and B minus. So, its value is given here, its value is given here. The sum is going to be taken into the consideration to talk about the equivalent conductance. And it is a pretty well useful for solving NCERT questions and NEET questions as well. And if you have a question from the electrochemistry, you can get it from either galvanic cell or you can get it from conductivity. If not, you are going to get Faraday's laws. And you can see limiting equivalent conductivity is going to be molar conductivity by N. As you know, normality is equal to molarity into N factor. But you don't say equivalent conductance is equal to molar conductivity by N factor. So, the N factor is the variable here. So, N is the total charge either on cation and or anion. You can take total magnitude charge, and this is going to be direct conversion from molarity to normality. Here the students makes a lot of mistakes saying that. So, normality is equal to molarity into N factor, but equivalent conductivity cannot be equal to molar conductivity n factor, but it is going to be divided by n factor. And you can say calcium chloride solution, you can say molar conductivity, as you already seen, calcium 2 plus and 2 into Cl minus, but equivalent conductivity directly you can do it, and you need not have to multiply with 2. Similarly, you have the charge, because the charge is the constituent and it is divided here, so that it will be just as it is. So, molar conductivity you multiplied with 2 and 3 here, but equivalent conductivity you need not have to multiply with 2 and 3. Directly equivalent conductivity of Al2SO4 thrice is equal to, and equivalent ionic mobility of aluminum plus equivalent ionic mobility of sulfate ion is the correct answer for these questions. And you see the charge values, Al 3 plus sulfate 2, so you are going to 2 into 3 or 3 into 2 is n factor is going to be 6. So, that equivalent conductance of Al2SO4 thrice is equal to molar conductance of aluminum sulfate divided by 6 is the appropriate answer, isn't it? If you have any doubts, use the chat box and let us know what you have exact doubt. And moving ahead, so to calculate applications of Kohlrausch law, actually we study Kohlrausch law and what are its applications is going to be noteworthy point, and definitely you are going to get a reasoning questions, and NEET examination आजकल reasoning questions में ज़्यादा ध्यान दे रहे हैं, so and you follow that. And first application is to calculate limiting molar conductivity of weak electrolyte like acetic acid and ammonium hydroxide, and we already seen a couple of things in before this. Okay, we'll see how to do with this acetic acid and ammonium hydroxide. So, it is going to be limiting molar values of strong electrolytes can be graphically measured, as you know it, because if you say the molar conductance and the root concentration, the strong electrolyte is going to be a straight line, and this straight line on extending you are going to get Debye-Huckel-Ansager equation के हिसाब से molar conductance you are going to get it for strong electrolyte only for strong electrolyte. Weak electrolyte you can't do it. So, the values of the weak electrolytes can be measured by adding and subtracting the constituent ions. So, like acetic acid can be done, and Kohlrausch law is used to evaluate molar conductivity of the weak electrolyte from the individual values of the strong electrolytes. And you can see acetic acid. ऐसे क्या कर सकते हैं? Acetic acid is equal to molar conductivity of acetate and H plus. So, from the data given in the question of the strong electrolyte, we are going to get it here. And you can see that infinite dilution alpha tends to almost 1. So, assume it is going to be a complete ionization. So, always you see Kohlrausch law, we assume it as an infinite dilution and we can calculate the molar conductance. And you can see this CH3COOH is going to give you CH3COO minus and H plus, and the limiting molar conductivity is equal to ionic mobility of acetate ion plus ionic mobility of H plus. So, this acetate ion, it is given as ACO minus. NCERT one question is given. You may surprise what is this ACO, means acetate ion. This is acetic acid, ACOH is given. So, it is going to be ionized like this. So, it can be done taking the HCl into the consideration, and you are going to take the sodium chloride into the consideration, you are going to get a sodium acetate into the consideration. All these three are strong electrolyte. When you subtract it from, you are going to subtract, add HCl and sodium acetate and subtract sodium chloride, which we don't need it. So, that ultimately you are going to get acetic acid molar conductance. So, HCl plus sodium acetate and subtract sodium chloride. It is the best equation that I can give you to understand the determination of molar conductivity of a weak electrolyte. And using this law, it is possible to calculate molar conductivity of an electrolyte. It could be either weak or strong from the data of the individual molar conductivities of the ions. So that is the conclusion, and moving ahead, and it is the second use of Kohlrausch law, my dear children. It is used to determine degree of dissociation, that is alpha. And from the Kohlrausch law, how we can do it? So alpha is equal to C alpha, Ka is equal to C alpha square by 1 minus alpha. You can recall something that is happened in the ionic equation. Ionic equilibrium sessions are also done, and if you have any doubts, just see in the channel. The previous lectures are there in the ionic equilibrium, how you got this. Alpha is the fraction of molecule that is ionized to the ratio of this total number of molecules, and greater the dilution, more is the ionization. So alpha nearly tends to 1 at infinite dilution according to Ostwald's law, and it is known as infinite dilution. From there, at any given concentration, you can say molar concentration, and at a given concentration, alpha can be determined by taking the ratio of the molar concentration of the electrolyte at and infinite dilution. You can also say alpha is equal to, you can write this and you can write this, okay. And based on this, you have so many questions from the previous NEET examinations as well. And you can say for the equivalent conductance also, at a given concentration, it is 0 concentration. And alpha value is a very good tool. You can say whether it is a weak electrolyte or a strong electrolyte. To say a weak electrolyte and a strong electrolyte, conductivity is the best experimental method, and you can individually say dissociation constant also you can calculate. Once you got alpha, so alpha is given as, you can say dissociation constant C alpha square by 1 minus alpha. As you know, alpha is equal to molar conductance at a given concentration, molar conductance at 0 concentration. Put that alpha by conductivity values and you can calculate how strong the acid is, and this is the best way you can say. As the Ka value increases, strength of the acid also increases, okay. And we discussed all the things in the ionic equilibrium. Here it is equal to Ka is equal to 1 C alpha square upon 1 minus alpha. We have alpha is equal to molar conductance at given concentration upon molar conductance at 0 concentration, and take these two values and put it here. You are going to get Ka is equal to C molar conductance square upon molar conductance at infinite dilution of molar conductance of infinite dilution minus molar conductance at a given concentration. And based on this, direct questions are there in the NCERT, and in text and solved questions it is there, and you can practice it. And no wonder if you get the same questions from the NEET examination, and definitely our lecture right now it is going on, it could be helpful for you a lot. And also you can see the third use of the Kohlrausch law is, it is used to determine the solubility, product and solubility of sparingly soluble salts. And whenever a sparingly soluble salt is saturated, and it has its solubility product constant Ksp. And the sparingly soluble salt, very small quantity solubility is there. And to calculate this, solubility is said to be specific conductance into 1000 by molar conductance at 0 concentration, limiting molar conductance. So limiting molar conductance ऐसे value है, it is going to give you answer for so many unsolved questions, and you just follow. Whenever you want to take the molarity, take the solubility and put it as a solubility, and you can get it. And moving ahead here, one more, and AgBr gives us Ag plus Br minus. So its a solubility, let us say S moles per liter, S moles per liter. So Ksp is equal to Ag plus and Br minus, and it is going to be S, and S is equal to S square. Ksp is equal to S square. So solubility is equal root over Ksp. Where do you get this solubility? Limiting molar conductance से आप निकाल सकते हैं, and you're going to see, and this is the best way to use Kohlrausch and other concepts in NEET as well as board. Hope you love this session and you can do the best in boards as well as in NEET. If you have any doubts in this particular session, please use the chat box or comment box and you can write anything, and you can clarify all your doubts. And please like this session, share with your friends and subscribe to Sri Chaitanya NEET channel. Thank you very much. Thank you.